Alex, I remember when the only way to slow down a drill press was a 5-minute wrestling match with a greasy rubber belt and a bunch of step pulleys. You'd end up with black knuckles and a motor that still groaned like a tired ox the second you hit some hardwood.
I've seen that look in your eyes, Tiger. It's the back in my day we walked uphill both ways through sawdust look. But seriously, you've got that little gray box wired up to your lathe now. It looks like a prop from a 70s sci-fi flick.
This prop is a variable frequency drive, a VFD. It's basically the brain for an AC motor. Without it, your motor is a dull instrument. It's either full tilt or stone dead. With this, I can make a 3-phase motor purr like a kitten at 2 RPMs or scream like a banshee at double its rated speed. It's transformed the shop. But man, the learning curve on these things is more like a sheer cliff face if you don't know what you're looking at.
Is that why I found you staring at the manual for 3 hours yesterday with a look of pure betrayal on your face?
I was trying to figure out the volts per hertz ratio for an old scrapyard motor I picked up. See, a VFD works by taking that steady 60 hertz hum from your wall, turning it into DC power, and then using what they call IGBTs or fancy high-speed switches, it pulses it back out as AC at whatever frequency you want. But if you give a motor high frequency without the right voltage, or vice versa, you're basically just making a very expensive, very smelly space heater.
So it's not just a dimmer switch for a motor, because that's how most of us think of it. Turn the knob, go slow.
Man, I wish. If you use a dimmer on an induction motor, you'll smell the magic smoke leaving the building in about 10 seconds. A VFD is much more surgical. It sits between the wall and the motor, and it's constantly negotiating. It says, okay, the boss wants 30 hertz, so I'm going to give you exactly enough juice to keep the torque up without melting your windings.
You mentioned 3-phase. Most of us in home shops are running on single-phase, just the standard plug. Is this where the magic happens? Can these things actually give me industrial power from a regular outlet?
That's the secret sauce for the modern maker. You find a heavy-duty industrial sander or a Bridgeport mill on Craigslist for pennies because it's 3-phase only, and everyone else is scared of it. But a lot of these smaller VFDs, up to maybe 3 or 5 horsepower, are designed to take that single-phase 220 or even 110 from your house and synthesize that third leg of power. It's like having a ghost in the machine providing that extra phase.
Okay, so I buy a cheap industrial beast, slap a VFD on it, and I'm a pro. What's the catch? You usually have a story about why cheap plus easy equals emergency room.
You're getting to know me too well. My first VFD install, I figured, hey, I'll just put this in a little wooden box to keep the dust off. I didn't think about the heat. These things have heat sinks for a reason. About 40 minutes into a heavy turning session, I smelled something like a crisping circuit board. I opened that wooden box, and the VFD was literally trying to desolder itself. These things need to breathe. If you're putting them in an enclosure, it needs to be NEMA 4X rated for washdown, or at least have a filtered fan that's actually moving air.
So, heat is the enemy. What about the motor itself? Can any old motor handle being told what to do by a computer?
Technically, yes, but there's a catch. Standard motors are cooled by a fan attached to the shaft. If you use the VFD to slow that motor down to 10% speed, that fan is barely moving. No air, no cooling. Meanwhile, you're still pulling torque. That's how you cook a motor.
So what do the pros do? Just run them fast all the time?
They use inverter duty motors. They have beefier insulation and sometimes an independent electric fan that runs at full blast, regardless of how slow the motor is spinning. If you're using a standard motor, you just have to be mindful. Don't let it lug at 5 hertz for an hour while you're hogging out material. It's like trying to run a marathon while breathing through a cocktail straw.
I noticed your VFD has about 50 buttons. Tell me about the programming side. Is it as soul-crushing as it looks?
It's more like a logic puzzle designed by someone who hates joy.
Accurate.
You have to tell the drive everything. What's the full load amperage, the FLA on the motor tag? What's the base frequency? If you get the FLA wrong, the VFD won't know when to trip the overload protection. I once saw a guy set his overload too high, and his motor started glowing like a stovetop element because the drive just kept shoving current into a stalled rotor. The VFD thought everything was fine while the motor was entering its molten phase.
So the VFD is also your fuse?
Exactly. It's a sophisticated safety net. It can detect a ground fault faster than you can blink. If a wire rubs through or a winding fails, the drive just shuts down and gives you an error code, usually something helpful like FA01, which then requires you to hunt through a PDF manual that looks like it was translated into 3 different languages before it hit English.
Okay, but it's not all just don't burn the house down. There are different modes of control, right? I've heard you talk about vector control like it's some kind of dark magic.
Because it kind of is.
See, your basic VFD uses volts per hertz. It just keeps a steady ratio. But sensorless vector control, that's where the drive actually calculates the magnetic flux in the motor. It monitors the feedback and guesses exactly where the rotor is and how much slip is happening. It means you can have massive torque even when the motor is barely moving. It's the difference between a car that stalls as soon as it hits a hill and one that just digs in and climbs.
And I'm guessing sensorless is the keyword there? Like, it doesn't need an actual physical sensor on the motor?
Right, it's just listening to the electricity. But if you want the absolute pinnacle, say for a CNC machine or a lift where you need to hold a load perfectly still, you go closed loop. That's where you have an encoder, a little heart monitor on the shaft, telling the VFD exactly what's happening in real time. But for most of us making furniture or tinkering with metal, sensorless vector is the sweet spot. It makes a cheap motor feel like a precision instrument.
One thing I've always wondered, when you hit stop on that lathe, it stops fast, like instantly. Is that the VFD too?
That's dynamic braking. When you tell the motor to slow down faster than it naturally would, that energy has to go somewhere. The motor actually turns into a generator. It starts pushing electricity back into the VFD. If that voltage builds up too much, the VFD gets a DC link overvoltage error and just gives up.
So how do you stop it?
You use a braking resistor. It's basically a big, finned toaster element that plugs into the VFD. When you hit stop, the VFD dumps all that excess generator energy into the resistor, which turns it into heat. It's the difference between a 3-minute coast down on a big, heavy flywheel and a 3-second controlled stop. It's a huge safety feature, but man, those resistors get hot enough to light a cigar.
I'll make a note. Do not use braking resistor as a coffee warmer.
You joke, but I've seen people mount them inside the control cabinet next to low-temp plastic wiring. That's a recipe for a bad Tuesday.
Okay, let's get practical. If I'm looking to upgrade a machine, how do I size the VFD? Is it just if it's a 2 HP motor, get a 2 HP drive?
Mostly, but keep an eye on the amps. Horsepower is a bit of a marketing number. The full load amps on the motor's nameplate is the truth. If your motor says 7 amps and your VFD is rated for 6.5, you're going to have a bad time. I always like to oversize the drive by about 20%. It's like buying a truck that can tow 10,000 pounds when you only have a 5,000-pound trailer. It just runs cooler and handles the stress better.
And what about line reactors? I saw those in your parts bin. They look like mini transformers.
They're basically filters. VFDs are noisy neighbors. They can kick back electrical interference into your house wiring, making your lights flicker or your radio buzz. Or, if your power from the street is dirty, it can fry the sensitive electronics in the VFD. A line reactor cleans things up on both sides. It's like a surge protector on steroids. If you've got expensive electronics in the shop, or if your VFD is more than 50 feet away from the motor, you really want one of those in the mix.
It sounds like a lot of extra hardware. Is the energy saving alone worth it?
In a home shop? Honestly, no. You won't see a massive dent in your power bill because you're not running a 50 HP pump 24/7 like a factory would. In industry, they save 30 to 50% on power by slowing down fans instead of using mechanical dampers. For us, the value is in the control and the longevity of the tools. Soft starting, where the motor ramps up over 3 seconds instead of slamming on, saves your bearings, your belts, and your gears from that initial violent jerk.
So it's less about the pennies and more about the peace of mind.
Exactly. And the versatility. I can take a machine built in 1940 and give it the finesse of a modern precision tool. I can dial in the perfect speed for a specific drill bit size in a specific wood species. It moves the craft from good enough to exactly right.
What's the biggest rookie mistake you see, aside from your wooden box of fire incident?
Wiring the output of the VFD through a switch.
Wait, why is that bad? Don't you want to switch?
You want a switch that tells the VFD to stop. You never want to put a physical switch between the VFD and the motor. If you flip that switch while the drive is running, it creates a massive electrical surge that can pop the IGBTs in the drive instantly. It's like trying to stop a waterfall by putting a piece of plywood in front of it. The water's going to find a way through, and it's going to be messy. You use the control terminals on the VFD for your buttons. The drive should always be hardwired to the motor.
So the drive stays awake, and you just tell it through a low voltage wire to go or stop.
Spot on. It's safer, it's cleaner, and your VFD will live to see your grandkids' projects. Plus, it lets you get fancy. You can wire up foot pedals, emergency stops, or even have a computer control the speed.
I feel like you're one step away from having a voice-activated lathe. Tiger Den AI. Spin at 400 RPM.
Don't give me ideas, Alex. I've already got enough wires in here to knit a sweater.
All right, so if I'm taking this away for my own shop upgrade, get the amps right, give it air to breathe, don't put a switch between the drive and the motor, and maybe don't trust the manual's first translation.
And remember that the VFD is a tool, not a miracle. It makes a good motor better, but it won't fix a motor that's already got a short or a bearings that sound like a bucket of gravel. Treat it like a brain. It needs the right inputs to give you the right outputs.
Fair enough. You've almost convinced me to stop being afraid of that three-phase beast sitting in the garage.
Just take it slow. Most of these drives have an auto-tune feature now. You put it in a specific mode, hit a button, and the drive actually sends pulses into the motor to feel its resistance and inductance. It learns the motor. It's like the machine is introducing itself to the computer.
Controlled, scientific, introduced self. I like it better than your way of just poking it until it smokes.
Hey, I'm a pioneer. I made the mistake so the rest of the den doesn't have to. But the satisfaction of hearing a 200-pound iron machine glide up to speed with a soft hum instead of a violent roar, that's worth every minute of manual reading and every singed eyebrow.
Spoken like a true craftsman.
At the end of the day, a VFD isn't just about speed. It's about the bridge between the old muscle of iron machines and the new precision of digital control. It gives you the power to be delicate with a machine that could otherwise crush a car. That's the real trick, mastering the force so you can focus on the finish.
I think that's a perfect place to leave it. Let's go see if that scrapyard motor of yours can actually spin without waking the neighbors.
Only one way to find out. Hand me that multimeter and maybe the fire extinguisher, just in case.
Classic.